With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A iron wire AB have diameter 0.6 mm and length 3 meter at 0 degrees Celsius. The wire is now stressed between opposite wall of a brass casing at 0 degrees Celsius. What is the extra tension that will set up in the wire when the temperature of the system is raised to 40 degrees Celsius? So if you see what will happen here, the tension will only raise here when the extension of this outer case that is made up of the brass. If you see, it is given that this is a brass casing, right? So this is a made up of brass and this is of iron. So I was saying that the tension will be only developed here when the extension of the brass will be more than the extension of the iron. Because what will happen when the iron will get more extended, then what will happen, it will become slack, right? If the iron extension will be more here, then what will happen, the iron will become slack and it will be, the tension will be zero here. So for this condition, the tension we want not to be zero, then the change in length of the brass should be more than the change in length of the iron. And you can see initially they both are having same length, right? So you can check this by checking this alpha. The one which will be having the more alpha will extend more. So if you see, the brass is having more alpha, so brass will extend more, because we know that the extension is proportional to, the change in length is proportional to the initial length, alpha initial length delta t, and delta t and initial length is same for the two, right? So if I calculate the change in length for the two, for the brass it will be alpha brass initial length change in temperature. For the iron it will be alpha iron initial length this. So what is the net increase, like if you see here, the alpha of this iron is less, so what will happen, because of the because this brass get more extended, so what will happen, it will stretch the iron. So how much there will be net strain here, net extension here, it will be this. By this much amount, this brass cage will extend the iron wire, that is alpha B minus alpha of iron into this. So from here I can write down the net strain that this iron wire is facing, because the brass got extended more, it will be equals to, if you see here, this is the net increase in length of the iron with respect to this brass, and it is equals to alpha B into delta T into L. So if you divide this term by L, I will write down L. So this will be the net strain, that is alpha B minus alpha I into delta T. But here we want the tension. So to get the tension, we will use Hooke's law, that is T by A is equals to times of strain. Since this is the stress, T by A is the stress, it will be equals to this gamma times of strain. So if you see in the question, it is given that the coefficient, like Young's modulus here, it is 21 into 10 to the power 10. So I will write down here T is equals to Ya times of alpha B minus alpha iron times of delta T. Now you can put the values here. So if you see, the diameter is the radius is given here, it is this. You can get the area of this, it will be pi d square by 4. So I will write down the diameter here is this, radius is this. So I will just put the value here. Here the Young's modulus is given in the question, it is this. Area, it will be pi r square. R is 3 into 10 to the power 4. So r square, it will be this. Alpha a minus alpha b, it will be 18 minus 12 into 10 to the power 6. If you see in the question, it is given that 18 into 10 to the power 6. And the radius, you could check, it is 3 into 10 to the power minus 4. And the Young's modulus is 21 into 10 to the power 10. Now, this expression we got, and the change in temperature, if you see, it is already given in the question, it is 40 degrees Celsius. So I will write here 40. So if you see, it is 21 into 9, it is 189 pi, into this will be 6 into 4, it is 24. Here it is 10 to the power 10 minus this 8 minus this 6 and this plus 1. So after solving, if you see, we got it is 189 pi into 24 into this is 11 minus 14, that is 10 to the power minus 3. If you multiply all this, you will get the tension is equals to 14.24 Newton, and this is the answer of this question. We wanted the tension developed in the iron wire and it is 14.24 Newton. Now you can check for the option. So A here is the correct one. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.